Hi everyone, welcome back. In this special request video, I'll be explaining Cayley Hamilton theorem. At the end of this video, you should be able to state without proof Cayley Hamilton theorem and some of its application. So one of the application, is to use Cayley Hamilton theorem to find the inverse. I'm going to, explain that how you can use it to find the inverse of a matrix. So then you are going to learn how to find the characteristics matrix, characteristics polynomial, characteristics equation, characteristics root, which is also the same thing as eigenvalue, and characteristics vector. So, but before I proceed, what is Cayley-Hamilton theorem? Cayley-Hamilton theorem. So when we say Cayley-Hamilton theorem states that every square matrix, let's say A, every square matrix A satisfy its characteristics equation. So from here, I'm going to explain what is characteristics equation. For example, you will have come across this type of matrix when I have A dot x is equal to lambda x. You understand now? So where your A is a square matrix, my A, let's say I have my Aij like this. So it is indeed a square matrix. So and your scalar, your lambda here is the what? Is the scalar. That is a number. You understand now? So this type of matrix, the one I've just shown here, the one you are seeing on the screen right now, that is A dot x is equal to lambda x. So it's a type of equation that occurs in many applications of matrices to technological problems. So that involves coupled oscillation and vibration. I hope you understand now. So from there, let's say I call this one equation one. Let's say this is equation one. If I call this guy equation one, then from equation one, I have that my A dot x equal to lambda x. So if you collect the like times by bringing this guy in, then I have A dot x minus lambda x equal to 0. You understand now? So you see now that you have x in common. I hope you understand now. So if you take this out, then I'm going to have A minus lambda x is equal to 0. So, but since you are dealing with matrix, so this lambda, which is a scalar, then you should not leave it that way. You understand now? So it means you are going to turn this scalar to a matrix. And how are you going to turn a scalar to a matrix? So you simply do that by multiplying it by what? An identity matrix. So a unit matrix or an identity matrix. So if that is cleared, so you will now see that I have an equation on my left hand side. I have something of this nature. So this expression is what we call characterities matrix. So what did I call it? Characteristics matrix. So that is when you have a square matrix A like this, and you now subtract lambda I from it. I hope you understand now. So then what you have here is what? Is known as characteristics matrix. Sorry, it doesn't include X. Characteristics matrix. Sorry, let me just clean it. That doesn't include X. Yeah. So, but this matrix alone is characteristics matrix. So I'm going to explain when it includes X. But don't forget, maybe I should just write it to avoid confusion. So this is A minus lambda I. So it is this expression that gives a characteristics matrix. I hope you understand now. So when you now take the determinant, that is the determinant of characteristics matrix, then you have what we call characteristics polynomial. Characteristics polynomial. And you know when you find the determinant and you now equate the determinant to 0, then we call it what? Characteristics equation. Then it has graduated from, characteristics polynomial up to a characteristics equation. So the value of lambda that satisfy this characteristics equation, so the value of lambda that satisfy this guy is known as what? Characteristics root. So characteristics root. In some textbook they call it latent root. You understand now? So it can also be referred as latent root or eigenvalue. So when you are asked to find the eigenvalue, it means you don't need to stress yourself. Just find the characteristics equation, and the value of lambda satisfying that particular equation is known as what? Your eigenvalue or latent root or characteristics root. You understand now? So when you now proceed further and you now find the value of x, the non-trivial value of x. You understand now? So I hope you understand what I mean by non-trivial values of x. So when you now have a non-trivial values of x, so that is the corresponding solution from here. Maybe you have for non-trivial value of x. So such that I have that my a minus lambda I, what I have the other time, x like this equals 0. I hope you understand that. So the corresponding solution of this given equation, you understand? Don't forget we obtain this equation from where? From ax. So from ax equal to what? Lambda x. So the corresponding solution of that given equation, so give what we know as what? Characteristics vector or an eigenvector. I hope you understand what I've just explained. So again, before we proceed, your a minus lambda I, so that if you want to find it, you don't need to stress yourself. This expression is what? Characterities matrix. So the determinant of this is what? Is your characteristics determinant, or you call it characteristics polynomial. It's called a characteristics polynomial because when you find the determinant, you have like a polynomial. So then when you equate your characteristics polynomial to 0, you have what? Characteristics equation. And the values of what? The values of lambda satisfying this guy. So the values of lambda, let me write it very well, satisfying a minus lambda I equals 0 is what? Characteristics what? Characteristics root. I hope you understand, or you call it latent root. And lastly, when you have this expression ax minus lambda x equals to 0, which is same thing as what? A minus lambda I x equals to 0. So the non-trivial values of x here, so is known as what? So when you solve it and you obtain, non-trivial values of x, then you have your eigenvector. So if that is cleared, let me give you an example to back it up. But before I proceed, don't forget when I stated the Cayley Hamilton theorem, I said Cayley Hamilton theorem states that every square matrix A, every square matrix A satisfies characteristics equation. So satisfies characteristics equation. So that is, at the end of the day, when you have your characteristics equation, let's say you have your it will be in terms of what? In terms of lambda. Maybe you have something of this nature. I'm going to explain in the in the follow-up example. Maybe you have something of this nature, let's say. You understand now? So you have lambda square minus 2 is equal to 0. So what Cayley Hamilton theorem is saying is that every square matrix A, you understand, irrespective of the element you have there, so far it is a square matrix, satisfy this characteristics equation. That is, when you now obtain, when you substitute the value of A that give rise to this characteristics equation, then you are going to have 0. It's satisfied. When we say something satisfy an equation, that is when you have x plus 2 equals 0, then you can say what? S equal to minus 2 satisfy this equation, because when you substitute the value of your s to be minus 2, you are going to have 0. So likewise, we say A satisfy this when you substitute the value of A, or when you replace lambda with A, then you have A square minus 2, then you are going to have 0. So that's what I'm going to explain in the remaining part of the video. And from here, one of the application of Cayley Hamilton theorem is that you can use it to find your what? So to find your inverse. You can use it to find your inverse. Okay, now let me give you an example to back it up to see what I mean. So example, I think I should just copy it here. Example, sorry. So let me just copy it there. I will give you one on 2 by 2 matrix. Remember, you can only find this on your what? On your square matrix. Okay, look at this question. There you go. Let me just expand it. So the question says, for each of the matrices below, you have to find the eigenvalues. Then you verify the Cayley Hamilton theorem and hence find the inverse of A. Recall the first matrix is what? Is a 2 by 2 matrix, that is a square matrix. And recall you can only find the determinant of a square matrix. Okay, let's start. The first question, you have your matrix to be what? 4 minus 1, 2, 1. And we have to find the eigenvalues. Remember, before you can obtain your eigenvalues, so it means you have to find your characteristics matrix, your characteristics polynomial, your characteristics equation, so your characteristics root, and from that root you find the values of what? The non-trivial s that satisfy, this equation. Okay, let us start. So I have A is equal to 4 minus 1, 2, 1. Since we know we cannot obtain my characteristics, root, the characteristics vector without finding the characteristics matrix. Okay, let us find the characteristics matrix. Don't forget your characteristics matrix is A minus lambda I. You understand now? Then if you substitute it, then I'm going to have 4 minus 1, 2, 1 minus what? So then you have your lambda here. Don't forget your I is identity matrix. Identity matrix for a 2 by 2 matrix is what? 1, 0, 0, 1. I hope you understand now. So then if you continue, then I have 4 minus 1, 2, 1. This is going to give me lambda 0. Lambda times 1. This is a scalar, you multiply it. Lambda times 0. Lambda times 1. So then if you simplify it further, I'm going to have something of this nature. Remember, if you want to subtract two matrices from each other, then you have to subtract the corresponding element. So that is row 1, column 1 of this matrix minus row 1, column 1 of this matrix. Then I'm going to have 4 minus lambda. Minus 1 minus 0 will give me minus 1. 2 minus 0, that is 2. 1 minus lambda is 1 minus lambda. So if you are asked to find characteristics matrix alone only, then you are going to have this matrix. So but the question asks us to find what? Characteristics vector. So then you continue. Don't forget you have to find your characteristics polynomial. Characteristics polynomial will now be the determinant of this matrix. Then I have 4 minus lambda minus 1, 2, 1 minus lambda. I hope you understand now. So then you can proceed from that. Don't forget how you find the determinant of 2 by 2 matrices. What you are going to do is what? Multiply this guy with this guy minus this guy with this guy. So this is going to give me 4 minus lambda, 1 minus lambda, minus 2 times minus 1, minus 2. I hope you understand. So if you open the bracket, I'm going to have 4 minus 4 lambda minus lambda plus lambda square plus 2. So then if you collect the like times, I'm going to have lambda square minus 5 lambda. I think this is 4 plus 2. 4 plus 2 will give me what? 6. So this is your what? Characterities polynomial. You understand? So if the question asks you to find the characteristics polynomial, this is your characteristics polynomial. Okay, now, but for your characteristics equation, you know, your characteristics equation means you are going to equate your characteristics polynomial, which is this guy, to what? To 0. You understand now? So then if you solve this guy now and have the value of your lambda, then you have the characteristics rule. That is the value of lambda that satisfies this equation. This is what this, a quadratic equation. Don't forget, we can quickly use our factorization method. So, or you use your any method of your choice. I hope you understand now. So your A here is 1, B is minus 5, and C is equal to 6. Your AC is equal to what? 6. Don't forget, if you have maybe the degree of this guy is 3, maybe you have, a cubic polynomial. You understand now? So, or your aquatic polynomial, maybe when you have a 4 by 4 matrix. What you have to obtain is that, what you have to notice is that if your matrix is a 2 by 2 matrix, then a 2 by 2 matrix give rise to a polynomial of order 2. 3 by 3 matrix give rise to what? Polynomial of order 3, and so on. So, in essence, a n by n square matrix give rise to what? Eh? Polynomial of degree n. I hope you understand. Don't forget, when you have a polynomial in degree n, you are going to have how many roots? N roots. So in essence, for this guy whereby my degree is 2, then I'm going to have 2 characteristics roots. I hope you understand now. So 2 characteristics roots. So your AC is equal to 6. So maybe when you have a 4 by 4 matrix, you expect to have 4 characteristics roots. It means you have to use your what? Eh? Rational root theorem. So if you don't know about that, refer to my previous videos on that. So then you now think of it. What is such a number you are going to multiply by itself to give you 6, and when you add them together to have what? Negative 5. So just think of the factors of 6. You know, there's one principle that states for two pairs of numbers that are factors of a number, when you multiply them together, I mean, for a factors of a number, let's say you have 6, 1, 2, 3, 6. So then you have two a pairs such that when you multiply the numbers in that pairs together, you are going to have 6. For example, 1, 6 is a pair, 2, 3 is also a pair. You can see that when I multiply 1 times 6, I'm going to have 6. 2 times 3 is going to give me 6. So sorry, plus or minus, plus or minus, plus or minus, plus or minus. Okay, now what is such pairs I'm going to take such that when I multiply them together, I'm going to have what? 6. And when I add them together, I'm going to have minus 5. I think that's minus 2 and minus 3. You understand? Because minus 2 minus 3 is minus 5. And minus 2 times minus 3 will give me what? 6. Then you now replace it with this guy. Then I'm going to have lambda squared. So lambda squared minus 2 lambda minus 3 lambda plus c is equal to 0. Then you now regroup and factor out the common factor. So what do you have in common? You have lambda here, then I have lambda minus 2, lambda minus 2. What do you have in common here again? Minus 3 is common. Lambda minus 2 is equal to 0. I hope you understand now. So you can see that lambda minus 2 is also common again. If you factor lambda minus 2 out, I still have lambda minus 3 is equal to 0. So then if you have two what? Expression, the product of two expressions to be 0, then it means either one of them is what? Is 0. Maybe you are in the room, two of you are in the room, and somebody polluted the air. You know, if it is not you, it is your friend. So then I'm going to have lambda minus 2 is equal to 0, or lambda minus 3 is equal to 0, which implies that lambda is equal to 2 or lambda is equal to 3. So lambda is equal to 2 or lambda is equal to 3 are what? Are your characteristics root. Oh, I hope you understand now. So which are also the same thing as what? Latent root or what? Or eigenvalue. I hope you understand that. So from here you can also find your eigenvector. So what is eigenvector? Then you are going to have what? A minus lambda I. Then you have your x here. So that is non-trivial x. So since you have 2 by 2 matrix, then you are going to have 2 values of x. So then I'm going to have, what is my A minus lambda I? From what I obtain here, that's 4 minus lambda. 4 minus lambda minus 1, right? 2, 1 minus lambda. I think that's that. 4 minus lambda minus 1, 2, 1 minus lambda. So then your x will now be what? X1, x2 is equal to 0. So then you can have 0 as a column matrix as well. You have 0, 0. So, okay, now if we proceed further, but before proceeding, remember that the value of my lambda here are what? 2 and 3. You understand now? You now say when lambda is equal to 2, then if lambda is equal to 2, if you substitute the value of 2 here, then I'm going to have 4 minus 2, 2 minus 1, 2, 2 minus 2, 1 minus 2, that's going to give me minus 1, x1, x2, 0, 0. I hope you understand now. So after that, if you just multiply this guy with this guy, then I'm going to have 2x1 minus x2 is equal to 0. So 2x1 minus x2 is equal to 0. So call this equation 1, call this equation 2. You can see this is a non-trivial, non-trivial. This will give you a non-trivial solution. I hope you understand that. You can just say from equation 1. So then your 2s1 is equal to s2, right? Which implies that your s1 is equal to s2 over 2. I hope you understand now. So then you can let your x2 to be any number except what? Except 0. You can say, let's say put s2 is equal to 1. Then it implies that my s1 is equal to what? 1 divided by 2. You understand now? Then you now conclude by saying the eigenvector corresponding to what? Corresponding to eigenvalue lambda is equal to 2 is what? 1, 1 divided by 2. I hope you understand now. You've done that for the first one. So for the first guy, you do that too. When lambda is equal to 3, when lambda is equal to 3, so what are you going to do after that? You substitute the value of lambda to be 3 here. If I put lambda to be 3, then I'm going to have 1. I mean this matrix again, you have 4 minus lambda minus 1, right? 2, 1 minus lambda, right? So then you have your x1, x2, 0, 0. So if you proceed further and put the value of your what? Of your lambda to be 3 now, then this guy lambda is equal to 3. Then you are going to have 1 minus 1, 2 minus 2, x1, x2, 0, 0. I hope you understand. So, and if you proceed further, then I'm going to have what? X1 minus x2 is equal to 0. So then 2x1 minus 2x2 is equal to 0. You understand now? You can see this one also give rise to what? A non-trivial. It will give you a non-trivial solution. So your x1 is equal to x2 from both equation 1 and 2. So from equation 1. So since it is a non-trivial solution, you say put x1 is equal to 1. So this implies that x2 is equal to what? Is equal to 1. You can use any value but not what? But not 0. That's you refer to my Phidion system of equation. So then you can say the eigenvalue corresponding to what? Sorry, eigenvector corresponding to lambda is equal to 3 is equal to what? 1, 1. So that's how you are going to find your what? So you are going to find your eigenvector. And in diagonal matrix, when you want to diagonalize a matrix, so this eigenvector is very, important there as well. I'm not going there in this video. So since that is clear, we were able to find our eigenvectors. So for two corresponding what eigenvalues, how do you now prove your Cayley Hamilton theorem? Don't forget, like I've said the other time, your Cayley Hamilton theorem states that every matrix A satisfy what? Characteristics equation. And don't forget, this is our characteristics equation. Let us go there again. We have that lambda squared minus 5 lambda plus c is equal to 0. Lambda squared minus 5 lambda plus c is equal to 0. So what Cayley Hamilton theorem is saying is that when you now put your A to be lambda now, when you replace lambda with A, when you substitute the value of lambda to be A, to be matrix A, then you are going to have 0. Okay, shall we try it? Then you have A squared minus 5 lambda plus 6. So we need to show that. Let me just change the marker. We need to show. So, and don't forget my matrix A is what? What is my matrix A? I have matrix A, that's 4 minus 1, 2, 1, everything squared, right? Then 5 into what? Lambda. So don't forget your, no, your lambda is going to be here too. Then you have 4 minus 1, 2, 1, then plus 6. We want to show is going to give me 0. Okay, let us try that. But since this is a scalar, you can just put I to make it a matrix. I hope you understand now. So, okay. But before we do that, we have to let us find the square of this. You know, the square of this will be 4 minus 1, 2, 1. Don't forget how you multiply matrix by a matrix. So, row with columns. So, then I'm going to have 4 times 4. That's going to give me 16 minus 2 minus 4 minus 1, 8 minus 2 minus 2 minus 1. I hope you understand. Then we are going to have something of this nature, 14 minus 5, 6 minus 3. So that's your A square. Then if you go back here, then I'm going to have, you have that your A square, I think, minus 5A plus 6 should give me 0, right? And my A square is this, my 14 minus 5, 6 minus 3. So then minus 5A. What is your A? I have that my A here is what? Don't forget 4 minus 1, 2, 1. 4 minus 1, 2, 1. I hope you understand. So then plus, and don't forget your C, since it is scalar, I said you are going to put this guy, your identity matrix. Identity matrix on that 2 by 2 matrix is what? 1, 0, 0, 1. Okay, now if you conclude, if you continue, you have 14 minus 5, 6 minus 3. Okay, if you multiply this guy by this guy, you understand now? Then I'm going to have minus, that is 20 minus 5, 10, 5. Then plus 6 is what? 6, 0, 0, 6. I hope you understand. So, okay. If you now simplify it further and you find the corresponding what? You simplify using their corresponding what? Position. So, here now, this row 1, column 1 with row 1, column 1 with row 1, column 1. 14 minus 20, that gives you minus 6. Minus 6 plus 6, that is 0. Can you see now? Minus 5 minus 5. So minus times minus is plus. Minus 5 plus 5 is 0 plus 0. That's also 0. 6 minus, sorry, 6 minus 10, that is minus 4, right? Minus 4 plus 0, then we made a mistake here. So let me remultiply this guy again. So we have 2 times 4, 8, right? Minus 2, which is 6, minus 2, minus 1. Let's say it again, 8 minus 2. So minus 2, minus 1, minus 3. That's 6 minus 3. And you have 4 minus, okay, let's try it again. So this is minus 10 minus 5. Okay, now 6 6 6 minus 10, that is minus 4. Yeah, then something is wrong. Yeah, I think I locate where the mistake is. So 2 times 4 is 8. This should be plus, and this will give me 10. So that's why you have to be careful when you are doing matrix. This is plus 1, right? 2 times minus 2, so plus 1. This will give me minus 1. Then it should be 10 minus 1. 10 minus 1. So then you will see that 10 minus 10 will give me 0, 0 plus 0. That is also 0. You understand now? Then minus 5 minus 5. That's minus 6 plus 6. That's also give me 0. You will see that my a squared minus what? Minus 5a plus c is equal to 0. Hence, matrix A satisfies Cayley Hamilton theorem. So satisfy Cayley Hamilton theorem. So, and how do you know the third question says we should what? After doing that, we should find what? The inverse of A. And then how are you going to use the Cayley Hamilton theorem to find the inverse of A? You don't need to use your adjoint in this sense. So you can use your Cayley Hamilton theorem together. It is very simple. How do you do that? Look up. So I have a squared minus 5a plus 6, which is equal to 0. I hope you understand now. So which is equal to 0. So then if I were you, I will just multiply through by A inverse. So if you multiply through by A inverse, then I'm going to have A inverse A square minus 5A plus 6 is equal to 0, or you can just say 6i anyhow. So then if you multiply through, then I'm going to have A inverse dot A dot A. You understand that, so as not to stress ourselves, because A dot A will give me A square minus 5 dot A inverse dot A, then plus 6 dot A inverse, which is equal to 0. I hope you understand now. You see that this guy will give me I. You know, when you multiply inverse by a matrix, you are going to have identity element. And identity times A, that's going to give me A, minus 5i, which is same thing as 5. You can write as 5. Then plus 6 inverse is equal to 0. Then you can rearrange it. Then I'm going to have 6 inverse is equal to what? 5 I minus A. I hope you understand that. Then your A inverse will now be what? 1 divided by 6, 5I minus A. I hope you understand now. So 1 divided by 6, 5I minus A. So if you now proceed, then your A inverse will now be 1 over 6. So we know that since this is a 2 by 2 matrix, 5 times I will be 5, 0, 0, 5. Then minus A, what's our matrix A? 4 minus 1, so 2, 1. I hope you understand now. So then you are going to have A inverse to be 1 divided by 6. So this is going to give me 1 minus 1 minus 2, 4. So, and that's your inverse. If you try it, you will see you are going to obtain the same result. You can try your adjoint. That's going to give you the same answer. If I were you, if you like, you can multiply through by 1 over 6, and this will give you 1 over 6 minus 1 over 6 minus 1 over 3, 2 over 3. So that's that. You can see we've done it for 2 by 2 matrix. What about 3 by 3 matrix? How are you going to do that? It is not difficult to do, but I will rush now. So since because of the time, since we know how to do it, I will just do it quickly. Okay, now let us try it again. Our matrix A now is what? It's a 3 by 3 matrix. Don't forget what I said, since it's a 3 by 3 matrix, then I'm going to have what? I'm going to have like 3 rows. My characteristics polynomial will be what? equation will be an expression in degree 3. You understand now? So then minus 1, minus 1, 2, 0. Okay, now let us do that. Then your characteristics matrix, don't forget that will be what? A minus lambda I. Before you can even know your characteristics polynomial, you have to find your characteristics matrix first. So which is what I'm finding here. Let me rewrite it, characteristics matrix. So then I'm going to have 2, 0, 1, minus 1, 4, minus 1, minus 1, 2, 0. Then minus into, then your lambda here is, your I here is 1, 0, 0, 0, 1, 0, 0, 0, 1. Since this is what? Since this is a 3 by 3 matrix. So if you simplify further, I'm going to have 2, 0, 1, minus 1, 4, minus 1, minus 1, 2, 0, lambda 0, 0, 0, lambda 0, 0, 0, lambda. So, and if you simplify further, then I'm going to have something of this nature. 2 minus lambda 0, 1. I'm subtracting. I hope you understand. So minus 1 minus 0 minus 1, 4 minus lambda minus 1. I hope you understand. So then this minus 1, 2, minus lambda. So you can use, okay, now let us now find the characteristics polynomial. So characteristics polynomial, statistics polynomial. Don't forget, characteristics polynomial will be the determinant of what? Characteristics matrix. So that is determinant of A minus lambda I, which is also the determinant of what? So I think I wrote 2 here so as not to, yeah. So then you have 2 minus lambda 0, 1, minus 1, 4 minus lambda minus 1, minus 1, 2, minus lambda. Okay, let us find the determinant. If I were you, I can use the first what? The first row. So I can find the minor of the first row. Don't forget your cofactor plus, minus, plus, right? So you will see the reason why I said that now. Then you have 2 minus lambda. You obtain the row by clearing the row as well as the column. Then this one gives me 4 minus lambda minus 1, 2, minus lambda. So minus 0. You don't need to take the minor because you know that even if the minor gives rise to, 1 million, the moment you multiply by 0, you are going to have what? 0. So then plus 1. Okay, you take the minor of this guy as well, minus 1. 4 minus lambda minus 1, 2. I hope you understand now. So if you continue, proceed from there, then I'm going to have 2 minus lambda. Okay. So you know this one will give you 4 minus lambda minus lambda. Since we are going to multiply, then this is going to give me plus 2. I hope you understand now. So then plus minus 2 plus, you understand now, 4 minus lambda. Let me rewrite it for 4 minus lambda. So if you continue, this is going to give me 2 minus lambda. You know, this guy, they are to multiply each other, then you are going to have minus 4 lambda plus lambda squared plus 2 minus 2 plus 4. That's going to give you plus 2 minus lambda. You understand now? You can see what you have in common here. 2 minus lambda is common. I can factor it out. So that will make my work easier. So then this is going to remain minus 4 lambda plus lambda square plus 2 plus 1. I hope you understand why I have plus 1, because you know I factored this guy out. This one will remain 1. I hope you understand now. So this is going to give me 2 minus lambda. Then you can have lambda square if you rearrange this guy, minus 4 lambda plus 3. So this is my characteristics polynomial. From here, I can obtain my characteristics what? Root. Characteristics equation. Don't forget, characteristics equation is what? Characteristics polynomial equals 0. So if you equate this guy to be 0, then I'm going to have 2 minus lambda lambda square minus 4 lambda plus 3 is equal to 0. So from there we can obtain our characteristics roots, that is the value of lambdas that satisfy this equation. So the value of lambda that satisfy this equation. So then that's going to give me what? Remember what I told you, if two expressions give 0, the product of two expressions is 0, it means either one of them is 0. Then you say 2 minus lambda is equal to 0, or lambda square minus 4 lambda plus 3 is equal to 0. From here, I can say that my lambda is equal to 2. If you simplify this further using factorization method, what is such a number? Pairs of 3, you are going to multiply by yourself. You are going to multiply them to give what? 3, and when you add them together to have minus 4, I think it is minus 1 minus 3. You understand that? Because minus 1 times minus 3 will give you 3. Minus 1 minus 3 will give you minus 4. Then you have minus lambda minus 3 lambda plus 3 is equal to 0. Then you can regroup. If you regroup, then I have lambda is equal to 2, or lambda is common here. This is going to give me lambda minus 1. Minus 3 is also common here. You are going to have lambda what? Minus 1 is equal to 0. Then lambda is equal to 2, or lambda minus 3 is also common. Lambda minus 1 is equal to 0. You understand now? Then you can say lambda is equal to 2, or lambda is equal to 3, or lambda is equal to 1. So it means your characteristics root or latent root or eigenvalue, they are what? Lambda is equal to 1, lambda is equal to 2, or lambda is equal to h, or lambda is equal to 3. You understand now? So that's my what? So that's my eigenvalue. And don't forget, I said from here you can find your eigenvectors, that is non-trivial values of s that satisfy this equation. A minus lambda I x is equal to 0. I hope you understand now. So what is my A minus lambda I? I know our A minus lambda I is what? Maybe I should just copy it. Let me just copy it so that we don't stress ourselves. Copy. Yeah. It will take some time. Just wait. Okay, if you paste it here, sorry. Let me just move here. I don't want to waste my time. No, it's still very close to it. No. Okay, so you have 2 minus lambda. So then you have what? You proceed further. You proceed further. Then you have your x now. Now your x will be what? 3 valued. X1, x2, x3 is equal to 0. I hope you understand that. So from here, you can just say when you do it for each of them. So when lambda is equal to 1. So when lambda is equal to 1, then I'm going to have what? 2 minus 1, that is 1, 0, 1, minus 1, 3, minus 1, minus 1, 2, minus 1. And for x1, x2, x1, x2, x3, maybe I will only find it for lambda 1. I will leave for the other values of lambda for you, so that I go straight to what? To the Cayley Hamilton theorem, and I prove it. Okay, now if you do this guy, then I'm going to have x1 plus x3 is equal to 0. I multiply this guy with this guy. 1 times x1 is x1, 0. 1 times x3 is x3 is equal to 0. And then I'm going to have what? Minus x1 plus 3x2 minus s3 is equal to 0. And lastly, I have what? So minus x1 plus 2x2 minus s3 is equal to 0. I hope you understand now. So How do you solve this guy? Yeah, it is very simple to solve. Let's say from equation 1, this is equation 1, equation 2, equation 3. So if I have from equation 1 now, I can have that my x1 is equal to s3 if I'm not mistaken. So if s1 is equal to s3, so then this one is going to give me what? Minus equation 2 is going to give me minus x1 plus 3x2 minus what? Huh? Minus x1. I hope you understand now. So it's equal to 0. So this one will now give me minus 2x1 plus 3x2 is equal to 0. So, and from there, you can say that minus 2x1 is equal to minus 3x2. So, which implies that your x1 is equal to what? 3x2 divided by 2. You understand now? So, non-trivial solution. So, you put x2 is equal to 1. If you put x2 is equal to 1, then your x1 is going to be what? 3 divided by 2. From here, you can find the value of your s3. Just put s1 is equal to 1. S1 is equal to 3 over 2, S2 is equal to 1 in any of the equation containing S3, maybe equation 3. And you know for your equation 3, I have minus x1 plus 2s2 minus x3. Minus x1 plus 2x2 minus x3 is equal to 0. Okay, let us substitute it. And this minus 3 over 2 plus 2x2 x2 is 1, right? That's 2 into 1 is equal to s3. I hope you understand what I did. So that's minus 3 over 2 plus 2 is equal to s3. If you find your LCM, so then this is going to give me 2 minus 3 plus 6 is equal to what? X3. So then your s3 will also be 3 divided by 2. I hope you understand. So s3 will also be 3 divided by 2. Then your x1, x2, s3 is equal to what? Minus 3 over 2, 1, 3 over 2. So which is the corresponding what? Corresponding eigen vector for lambda is equal to 1. So for lambda is equal to 1. So you can see it is as simple as that. That's the corresponding for lambda is equal to 1. So I leave the rest for as uh, an exercise for you. So find it when is equal to 1, when is equal to 2, and when is what? Find when is equal to 2 and when is equal to 3. We found when is equal to what? When is equal to 1. Okay, now let us now prove our Cayley Hamilton theorem. Don't forget Cayley Hamilton theorem states that every matrix A satisfies characteristics equation. And what is our characteristics equation here? My characteristics equation here is what? This guy. We have 2 minus lambda. Let me rewrite it here so that I can expand because I didn't finish with the expansion here. Lambda square minus 4 lambda plus 3. Lambda square minus 4 lambda plus 3 is equal to 0. I hope you understand now. So if I open the bracket, this is going to give me 2 lambda squared minus 8 lambda plus 6 minus lambda cube plus 4 lambda minus 3 lambda is equal to 0. I hope you understand now. If you collect the like times, so I have minus lambda cube. So what do you have left? I think we have plus 2 lambda squared. And this minus 8 lambda plus 4 lambda, that is minus 4 lambda. I hope you understand now. So this will give me minus 4 lambda. Let me multiply it again. 2 lambda squared minus 8 lambda plus 6 minus lambda cube plus 4 lambda. This should be plus 4 lambda squared. Sorry, I made a mistake. Plus 4 lambda squared and minus 3 lambda. So it means this should be 6 lambda squared. So it should be 6 lambda squared. I hope you understand now. So what else? If this is 6 lambda squared, what else do I have? Because we have to be careful here so that we don't make a mistake. We've taken this guy, we've taken this guy, we've taken this guy. Okay. Then I have minus 11 lambda plus 6 is equal to 0. So if you want to show Cayley Hamilton theorem now, if I were you, I can multiply through by negative, then I have lambda cube minus 6 lambda squared plus 11 lambda minus c is equal to 0. So from here, you can just put lambda is equal to A. You understand now? You know that's what you are going to do to see whether your matrix A satisfy it. And I'm going to have A cube 6A squared plus 11A minus C is equal to 0. So we want to show that, this expression, is equal to 0. Okay, let us do that. What is my A again? So that I don't make a mistake. Recall that my A is what? So our matrix A is 2, 0, 1, minus 1, 4, minus 1, minus 1, 2, 0. So let me find A squared. Then after that, I find A cube and see what I'm going to have. Okay, now this is 2, 0, 1, minus 1, 4, minus 1, minus 1, 2, 0. Okay, let us multiply. This is going to give me 4, 0, minus 1. You understand now? So again, this is going to give me 0, 0, that is 2. I hope you understand what I'm doing, row with columns. So 2 times 1, 2, 0, 0, right? Okay, this times this, that is minus 2, minus 4, this plus 1, because minus 2, minus 4 plus 1. Okay, and this is going to give me 0 plus 16 minus 2. And lastly, this is going to give me 1 minus 4 plus 0. Okay, let us do the third column. Then I'm going to have minus 2. You have to be careful. Minus 2 so that you don't make a mistake, plus 0. And this is 0 plus 8 plus 0. And lastly, this is minus 1 minus 2 plus 0. Like one of my master used to say that if you are doing this kind of matrix, we need 3 things from you: your eyes, your ear, and your mind. So this is 3, this is 2, 2. So minus 6 plus 1, that's going to give me what? Minus 5. This is 14. You understand now? So this is 14. And minus, I think this is 0, that is minus 3, minus 4, 8, minus 3. Okay, now we still find what? So you still multiply this guy by A to have your A cube. Your A cube will be 3, 2, 2, minus 5, 14, minus 3, minus 4, 8, minus 3. We have to ensure we don't make a mistake. And what is my A again? 2, 0, 1, minus 4, minus 1, 4, minus 1, minus 1, 2, 0. I hope you understand now. So if you multiply it again, then I'm going to have what? 6 minus 2 minus 2. Again, this is going to give me what? 0 plus 8 plus 4. And lastly, this is going to give me 3 minus 2 plus 0. Okay, this is going to give me minus 10 minus 14 minus 10 minus 14 plus 3. This is 0 minus 5 times 0 is 0. So 14 times 4, that is 56. Minus 0 plus 56 minus 6. Right? I hope I don't make a mistake. And lastly, I have minus 5 minus 14 plus 0. So lastly, do the last column as well. So please, you have to be careful so that we don't make a mistake. Unfortunately, I don't know whether I've made a mistake here or not. So minus 8 plus 3, 0 plus 32 minus 6 minus 4 minus 8, 0. Okay, let's do it. This guy will now give me 6 minus 2, 4 minus 2, that is 2. This is 12. This is 1. Minus 10 minus 14, that's minus 24. Minus 24 plus 3, that's minus 21. 56 minus 6, that is 50. So minus 6, minus 5 minus 14, that is minus 19. Minus 8 minus 8 minus 16 plus 3, that is minus 13. 32, that is 26. And minus 12. Okay, let us go there again. What is our equation? We have a cube a cube. So we have a cube minus 6a square plus 11a minus 6a square plus 11a minus 6, Abi. So we want to show it is 0. Minus 6a square plus 11a minus, yeah. Okay, now then you have to include I here so that you don't make a mistake. What is my a cube? I think that is 2, 12, 1 minus 21, 50 minus 19 minus 13, 26 minus 12. Then minus 6 times a squared. Let me just multiply it there so that I don't stress myself. If you multiply this by 6, this is going to give me 18. Let me just write it. 18. So 6 times 3, that is 18 times 2, 12. 12 minus 30. And 14 times 6, this is 4, remainder 2, 6, 84 minus 18. I hope you understand what I'm doing. Minus 24, 48 minus 18. Let me just write it here. So 18, 12, 12 minus 30, 84 minus 18, 24, 48 minus 18. Okay, let us just copy it there so we don't need to stress ourselves again. So that's going to be 18, 12, 12 minus 30, 84 minus 18, 24, 48 minus 18. Okay, then the third time, that's going to be 11 times A. That's going to be plus 11. What is 11 times A? Recall your A is 2, 0, 1, minus 1, 4, minus 1, minus 1, 2, 0. So if you multiply it by 11, or let me just, I don't want to rewrite it again because of the space. This is 22, right? If you multiply it by 11, 0, 11, minus 11, 44, minus 11, minus 11, 22, 0. And lastly for 6, that's minus 0, 0, 0, 0, 6, 0, 0, 0, 6. Okay, let us prove whether this is going to give me what? Whether this is going to give us 0. Let's see if it's going to give us 0 matrix. Yeah, so the first one, 2 minus 18, that's minus 16. You understand now? So minus 16 plus 22, that's 6, and 6 minus 6 is going to be 0. Bravo, très très bien. Okay, let us do the second one. 12 minus 12 is 0, plus 0, 0 plus 0, 0. Bravo, très très bien. Okay, 1 minus 12, that is minus 11. Minus 11 plus 11, 0. 0 minus 0, that is 0. Bravo, excellent, très très bien. So, let us proceed. Let us do the second column, minus 21 plus 30. You know, minus 30 minus will be a plus. So that is 30 minus 21. I think that is 9. 9 minus 11. 9 minus 11. Let me do it again. Yeah, minus 21 plus 30. That is 9. 9 minus 11 minus 2. It means we made a mistake here, so you have to check. Let us do the second one. 50 minus 84. 50 minus 84, that's minus 34. Minus 34 plus 44, 10. Yeah, I think there is an error in this column, maybe when we were multiplying. So you have to check. Let us check the last one, maybe. Minus 13 minus 24. Minus 13 minus 24 is minus 37. Minus 37 minus 11. So minus 34 minus, so then minus 11. Yeah, there's an error here. So I think when we were multiplying, we've actually made a mistake. So I will advise you to check. If you check it very well and you ensure there is no mistake while you are checking, you will see that the other columns are going to be 0 as well. I hope you understand now. So then you can conclude that this is equal to 0. I hope you understand now. So that's, if this is 0, then you conclude that hence matrix A satisfies characteristics equation. So, and how are you going to find your inverse from that? From there, you know, one of the application of Cayley Hamilton's theorem is you can use it to find an inverse. You have a cube minus 6a squared. Yeah, I think I understand where we made a mistake now. We're supposed to multiply this by minus 6. So we have to multiply it by minus 6 and just check. Okay, we have a cube minus 6a squared plus 11a minus 6 plus 11a minus 6 is equal to 0. So then you can multiply through by inverse. You have a cube minus 6a squared plus 11a minus 6 what? 6i is equal to 0. If you multiply through by inverse, this is going to give me a squared minus 6a plus 11 minus 6a inverse is equal to 0. So then you can have your a squared minus 6a plus 11i, which is equal to what? 6a inverse, right? So then your a inverse is going to give me what? 1 divided by 6 into what? A squared minus 6a plus 11i. So then your a inverse will now be 1 over 6. What is matrix A squared? I think that is 18, 12, 12. 18, 12, 12. minus 30, 84 minus 18, 24, 48 minus 18. I hope you understand now. So then minus 6a. Minus 6a, if you multiply 6 by a, I think this is going to give me 12, 12, 0, 6, minus 6, 24 minus 6, minus 6, 12, 0. You understand? And then plus this, that's 11, 0, 0, 0, 11, 0, 0, 0, 11. You understand? And then your A inverse will now be what? 1 over 6 into 18 minus 6, that is 6. 18 minus 12, that is 6. 6 plus 11, that is 17. 12 minus 0, that is 0, right? 12 minus 0, that is 12, sorry. So 12 minus 6, that is 6 plus 0, that is 6. Okay, minus 30 minus 6, that is plus. Minus 30 plus 6 will give me minus 24. Minus 24. 84 minus 24, that is 60. Then you have 60 plus 11, that is 77. Then lastly, minus 18 plus 6. Minus times minus, that will give you minus 12 plus 0. And lastly, 24 plus 6, that is 30, plus 0, that is 30. 48 minus 12, that's going to give you 36. 36 plus 0, that is 36. And lastly, minus 18 minus 0, so that is minus 18, minus 18 plus 11, so that's going to give me minus 7. So then your A inverse, you can check it out if you've not made a mistake. It's going to be 1 over 6, 17, 12, 6, minus 24, 77, minus 12, 30, 36, minus 7. I hope you understand now. So if that is cleared, please don't forget to like my channel, subscribe and tell your friend to do so. So now I assume you understand what is Cayley Hamilton theorem. So which states that for every matrix, a square matrix A, so then it satisfies its corresponding characteristics equation. And I think you've understand what is characteristics matrix as well. Characteristics polynomial, characteristics equation, characteristics root, and characteristics vector, which is eigenvalue and eigenvector respectively. And now you are going to obtain them. Thank you.